In today's OpenGL demo, I'm showing off this scene that uses deferred rendering. So as you can see here, we have this scene and it has 15 rocks in it, and each rock has a light above it. And you can see we can fly around and the performance is pretty stable and it runs well, even though each of the 15 lights shines on all the rocks around it. So to show off how this works, let's go into the code. And the main way this works is that we have this buffer, or this frame buffer up here, and we create three textures and attach it to it. We attach a G position, a G normal, and a G color. And then what we do is when we render the scene, we first render all 15 rocks, and we use this frame buffer. And then in the second time we pass through, we use a quad, so like just two triangles on your screen, and we draw all three of these textures to that quad, and then that's what we see here. And the interesting part is we do all of our lighting calculation in this quad, which I'll show you. So in our regular vertex and fragment shader, we simply pass GL position as frag position, GL normal as normal, and GL color as texture of the rock. So we just simply pass these into these three variables and we output them. And we output them location 0, 1, and 2. And then this is picked up by the frame buffer right here, position, attachment 0, 1, and 2. And then in our depth vertex and fragment shader, which is what the quad uses, we take in three textures, G position, G normal, and G color, and then we take in 15 lights. And what we do is we extract those back out. So we take a frag position, a normal, and a color. And then if color A is, or if the alpha value is 0, we discard it, which is just, the first time we render it, we have a clear color of 0, 0, 0, 0. And then the second time we set the actual background color. So this just says if it's the old background color, leave it transparent in essence. And then we calculate lighting, which is the color times 0.1. So this is all the ambient lights. And then we calculate a viewer. And then for each of the lights, we get a distance. And this is their light position minus frag position. And if the distance is less than radius, which is a variable we pass in here, and it's this equation right here, it calculates the volume of a sphere. So if this fragment is within a sphere's radius of the light source, then we calculate lighting. Oops. And for lighting, all we do is we first check if it's close within 2.5, and if it is, then we run this equation here where we add the color times the light's color times 2.5 minus the distance. So what this does is the closer you are to the light source, the more and more direct light you'll get on it. And then if it's not there, or if it is afterwards, we calculate a light dir, and then we add the dot of normal and light dir times color times the light's color. So this gives us the effect if we run it where the parts of the rock that are closest to the light get just the direct color, and then once you move away from that, you kind of get a mix of the other colors, and it depends on the angle. So this part of the rock here isn't this teal color, because if we look, this cube can't actually see that part, so the light only shines where it can see. And then once we back in the main file, this determines all this, and then, or this part is the quad shader, which we just covered, and then afterwards we bind the read fragment to the buffer, but the draw fragment back to default, and then we blit frame buffer. And what this lets us do is it allows us to draw all of our lights, all those cubes you can see, onto the scene after we've calculated the quad. So we can actually disable the quad, and I can show you. So if we comment this out and then run it, you can see that all the lights still show up. And we can actually like fly behind a rock still. and it will hide. See, like right now we're under a rock, so that one over there that I'm zooming in on it gets like half covered up. But if we re-enable the quad, it will redraw all the rocks and all their calculated lights. If you found any of that stuff interesting, you should click on this video here where I have a much simpler scene involving one light cube and one brick cube, and show off a bunch of special effects, including a parallax map. And until next time, see ya!